Welcome to all. Today we are going to discuss on the topic that is periodic classification. We know different elements have been discovered. They have different physical and chemical properties. To remember their properties systematically, different scientists have attempted different ways to remember their properties systematically. These are called periodic laws. Scientists like Doberiner of triads, Newlands law of octaves, Lothar Meyer, Mendeleev, and Henry Moseley. These are the few scientists involved in the classification of elements. Classification elements means systematic arrangement of elements in a tabular form. The similar elements grouped together and separated from dissimilar elements. Let us discuss what are the different periodic laws stated by different scientists for the arrangement of elements in a tabular form. First is Doberiner of triads. Doberiner is German chemistry in the year 1817. He first attempted to arrange the different elements in a systematic way, and this is called Doberiner of triads. He took three elements in a group called triads. He took three elements in a group called triads. So number of triads he made, and these triads are arranged in a systematic way in increasing order of atomic mass. So Doberiner showed that when the three elements in a group called triad were written in the order of increasing atomic mass, the atomic mass of the middle element in the triad is the average of other two elements. That means he made some triads taking three elements. The atomic mass of middle element will be the average of atomic mass of other two. During his study, he made so many triads, but some drawbacks he had, that the elements which were discovered in that time all were not fitted in his table, in his triads. All elements were not fitted in the triad. This is the first drawbacks. Another is the elements could not be arranged in the form of triads due to their different behaviors, and it has been observed that in the triad the elements which has low atomic mass are arranged together in triads, but it differ from high molecular mass. High molecular weight elements were not fitted in the triads. So this is the one important drawbacks of Döberiner's triads. Next, the second law, that is Newlands of octaves. Newlands of octaves, that is English chemistry. He was English chemistry in the year 1865. He made this table, that Newlands of octaves periodic table, and this is mainly based on the property of atomic mass. That means elements are arranged in increasing order of atomic mass, in such a way that the properties of eighth element, after finishing the seven elements, the eighth element, the property is the repetition of first. That means he arranged the elements increasing order of atomic mass. That means he selected the property, that is atomic weight is the fundamental property in the arrangement of elements. Just like the musical notes, musical octaves of notes, that means sa re ga ma pa dha ni, these seven musical notes arranged starting from sa and ended at ni. When it will start, then again sa will come. So he arranged the elements in such way that the eighth element, its property is the repetition of first. That means he arranged the tabular form, taking the musical notes sa re ga ma pa dha ni, like this: hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen. These are the seven elements. Then the eighth element coming to hydrogen position: fluorine, sodium, magnesium, aluminium, silicon, phosphorus, sulfur. Then next element coming to fluorine position. So like this, the eighth element is the property of first, ninth element is the property of second. Like this, some repetition in the properties he found. So this table is called Newlands law of octaves periodic table, and the property mainly based on increasing order of atomic mass and arrange the elements in musical notes, like musical notes, octaves of musics, and the property of eighth element is the repetition of first. What are the drawbacks of his table? Drawbacks is lighter elements mainly occupying his table. Mainly lighter element, for lighter element the table was suitable, but for heavier element the table was not suitable. That means for heavier element he could not place these heavier elements in his table. So these are the main drawbacks. That means elements which were discovered in that time were not fitted in his table, were not selected in his table. So this is the drawbacks of Newlands of octaves. Okay. Then Lothar Meyer, that is third scientist, attempted in the arrangement of elements, that is the German chemistry in the year 1869. Lothar Meyer individually he arranged the elements in increasing order of atomic mass, but taking so many properties like atomic size, atomic volume. He compared the atomic size, atomic volume with atomic weight, that is atomic mass. So he plotted a graph, the versus atomic volume versus atomic mass, and he found with increasing atomic mass the graph also changes, but the similar elements having similar properties, are occupying same place in the graph. Just you see the tip of the graph, suppose here sodium, potassium, rubidium, these are called alkali metals. These are the metals having similar properties that are occupying in the tip of the graph. Similarly, just below you see fluorine, chlorine, bromine, just below the tip of the base of the graph. So that means when he plotted the graph atomic volume versus atomic mass, the similar elements occupying in the same place of the graph. That's why he found that the properties of similar properties of elements are grouped together, can be grouped together. So this is called Lothar Meyer periodic laws, and he selected atomic weight is the periodic properties of the elements versus atomic volume, atomic size. Okay. Now, what are the drawbacks? The major drawbacks is the table was incomplete. The table of Lothar Meyer was incomplete, and he selected many properties and taking atomic mass as the comparison with other. So many properties were considered to compare with the atomic mass. So it was difficult to remember the properties of elements systematically. So this is the one important drawback is he considered many properties to compare with the atomic weight. That's why this law was not accepted 100% by modern scientists. Next attempt was taken by Mendeleev's. Mendeleev's table was somewhat accepted by modern scientists because many elements were selected and were fitted in his tables. What are the properties, what are the periodic laws of this Mendeleev's? The law states that chemical and physical properties of elements are the periodic function of their atomic weight. That means the properties of elements changes with respect to atomic weight. By changing the atom weight, the property changes. The physical property and chemical property are the periodic function of their atomic weight. He also selected the periodic properties is atomic weight. That means he selected the properties that is atomic weight versus other physical and chemical properties on the basis of atomic weight. And he was a Russian chemist in the year 1869. He made this table, and this table is called Mendeleev's periodic table, and the law is called Mendeleev periodic law. You see the features of his table. The periodic table is composed of 7 horizontal rows that is called periods, and 8 vertical columns called groups. Just you see that here this is called periods, horizontal rows. So 7 horizontal rows called periods, and 8 vertical columns are called groups. So 1 to 8 vertical columns here, and 7 periods, top to left to right, that is periods, and top to bottom, that is groups. And the periodic table is composed of 8 vertical columns, that is called groups, and he also given as each column as A and B, divided into A and B. Two subgroups. Each group is divided into 2 subgroups, A and B, subgroups. When Mendeleev started his work, that time 63 elements were known. That means maximum 63 elements were selected in his table. And he also selected some formula like oxides and hydrides of these elements. By knowing the formula of oxides and hydroxides, he was able to know the valency of the elements. So as per their valency, he placed the elements in different groups. As per the valency, he selected elements in different groups. So that's why he selected the formula like hydrides and oxides of elements. From the formula, he was able to know the valency of the elements and their columns, and that is their groups. So these are some points of Mendeleev's table. Then what are the merits of Mendeleev tables? The first merit is give more weights to similarity in his properties. That means during arrangement he mainly emphasized the similar properties of elements. Although he arranged the elements in increasing atomic weight, but he gave more emphasis the similarities in properties. Some cases he found that the properties may be same, but the atomic weight may be not as per the increasing order of atomic weight. Some cases, some difference also he observed, but given main emphasis in similarity in properties. Then correction of atomic mass. That means he, during his arrangement, he also corrected the atomic weight of some elements. Elements of beryllium, indium, gold, platinum were predicted to be having incorrect mass. Then he stated that he corrected some atomic weight of elements. Prediction of new elements. That means during his arrangement, he used some term, ekka prefix, some prefix, that is ekka is used, that indicates the elements of next elements of this group. For examples, aluminium, silicon and germanium. Aluminium, silicon and germanium, these three elements, their name was ekka boron. Then gallium is ekka aluminium. Then germanium is ekka silicon. That means ekka boron means aluminium, ekka aluminium means gallium, ekka silicon means germanium. So using this prefix ekka, he had given the name of the elements, next member of these groups. And during his discovery, noble gases were also discovered later. Since they show inert behavior, zero valency, they could be easily attached to the Mendeleev table. That means due to their zero valency, it is separated from other elements. Then some vacant space left. You see the table, some vacant space he left. These are the vacant space left by the Mendeleev, and this vacant space was fitted the elements which were discovered later. In the vacant space, some discovered elements which was discovered later could have been fixed in the vacant space. So this is the some merits of the Mendeleev periodic tables. Then what are the demerits of Mendeleev table? Let us discuss. He was unable to locate hydrogen in the periodic table. What are the particular fixed position of hydrogen he could not assign. And increase in atomic mass was not regular while he arranging the elements. While he was arranging the elements, the increasing atomic weight, increasing atomic mass was not followed. That means mainly he gave emphasis the properties but not given more emphasis in the increasing order of atomic mass. Some cases atomic mass may be high, may be low during arrangement, but the property was satisfying. The latter, the isotopes elements were found which violated Mendeleev. That means there was no position of isotopes in the periodic table, in the Mendeleev periodic table. Elements having different properties were placed in same groups, like your manganese was placed with halogen. So different elements, different properties elements also placed in one group. So these are some drawbacks, and there is no particular position in the table, in the periodic, in the Mendeleev table of lanthanides and actinides. Lanthanides and actinides were not given proper place in the Mendeleev table. So these are the some drawbacks of Mendeleev periodic laws, that is Mendeleev periodic table. Then last attempt, that is very important periodic law, that is modern periodic law stated by Henry Moseley. Henry Moseley mainly gave the emphasis on atomic number, not atomic mass. According to Moseley, that physical and chemical properties of elements are the periodic function of their atomic number, not atomic mass. That means he arranged the elements in increasing order of atomic number, not atomic mass. So far that periodic laws we have discussed now, all have taken atomic mass, but modern periodic law based on atomic number, and the prediction of properties of elements could be made with more precision when the elements were arranged on the basis of their atomic number. That means it will be very easy in the prediction of properties of elements on the basis of increasing atomic number. Atomic number indicates the number of electrons present in outermost cell. That's why he selected atomic number. The properties, some physical properties, some chemical properties elements also based on the electronic configuration arrangement of elements in the atom. That's why he had taken atomic number as the periodic properties of the elements. Then some features of this table is the elements in the table were arranged increasing atomic number, not atomic mass. The horizontal rows are called periods, already discussed, and vertical columns are called groups. The modern periodic table consists of 7 periods. Horizontal periods 7 and vertical columns are called groups, that is 18. The table is classified into 4 blocks. The whole table is divided into 4 blocks like S, P, D and F block. S, D and F block mainly metals and P block mainly non-metals. So there is a difference in the position of metal and non-metals. S, D and F block mainly contain metals and P block mainly contains non-metals. And F block elements, these are called lanthanides and actinides. And the metals, non-metals and metalloids are placed separately. Already we discussed metal, non-metals and metalloids already separated from each other. That means from their position is fixed. Metal, non-metal and metalloids. Then you see this is the modern periodic table. Here the table is, it has different colors indicating different groups of elements. We will discuss one by one. This modern periodic table it consists of 7 periods, 1, 2, 3, 4, 5, 6, 7 periods, and these are vertical columns called groups. How many groups? 18 groups. 18 groups, 1 to 18 and 7 periods. So what are the individual groups? Let us discuss. The first group is called alkali metals. This is the first group. This is called alkali metals. This is the first group. Is called alkali metal except hydrogen. Except hydrogen, these are called alkali metals. And second group is called alkaline earth metals. Second group is called alkaline earth metals. And the first group and second group both are S block elements. These are called S block. S, P, D and F block elements on the basis of their arrangement of electrons. If the last electron enter into S, P, D and F subcell, then the elements will be in that block. If the last electron entering S subcell, that is called S block, because subcell means each cell is divided in number of subcells like S, P, D and F. So the last electron entering to that subcell, it will be same group, that group. So first group and second group are called S block elements. First group are called alkali metals except hydrogen. What are these? Lithium, sodium, potassium, rubidium, cesium and francium. And second group are called alkaline earth metals, beryllium, magnesium, calcium, strontium, barium, radium. And what are the characteristics of these groups? All alkali metals are highly reactive compared to second group. And these all are in solid state. All first group and second group all are in solid state. These are the reactive metals, but group 1 is very reactive. Group 1 contain 1 electron in their outermost shell. Group 2 that is second group, contain 2 electrons in their outermost shell. Generally, on the basis of number of electrons available in the outermost shell, they are also given the group. 1 electron in outermost shell, so first group. 2 electron in outermost shell, that is called second group. So this is called alkali metal, this is called alkaline earth metals. Okay, and alkali metals mainly contain 1 electron in outermost shell, valence electron is 1, and second group, that is alkaline earth metal, contain 2, that is valency 2. Then middle, that is just you see the table, this middle, this is called D block elements, and this is called transition element. This is called transition elements. What are these transition elements? Let us discuss. Transition elements again divided into how many periods? First period, second period, third period, fourth period. On the basis of that is all transition elements, D block elements divided into 5 periods. These are called 5 series. First series, second series, third series, fourth series. Okay, and these are the some important elements like your iron, nickel, copper, zinc, mercury, silver, gold, so many types of platinum. These are the called D block element. That means the last electron, their last electron enter into the D subset. That's why these are called D block elements, or it is called also transition elements. It's just comes just after alkaline S block, then D block, then P block. That's why it is a transition state in between the S block and the P block. And what are the properties of D block elements? Let us discuss. The properties of D block elements, these are very important properties you have to remember. High melting and boiling points. All transition elements have high melting and boiling points, and these have very good magnetic character. When they will be attracted towards magnet, these are called paramagnetic. When they will be repelled by the magnet, this is called diamagnetic. So they have good magnetic character, and they are very hard and high density. High density means heavier, and they also behave as catalytic property. That means these elements and their compounds behave as catalyst and show variable valency. The element shows variable valency, more than one valency they shows. You know ferrous valency 2, ferric valency 3, already you have read. So they have variable valency. And other properties, they produce color compound. The elements also are colored and their compounds also almost are colored. And their oxide and hydroxides are less basic compared to alkali and alkaline earth metal. Their oxides and hydroxide are less basic compared to S block elements. Okay, so these are again I am repeating the properties of transition element. They are very high melting and boiling point. They show very good magnetic behavior, paramagnetic behavior, diamagnetic behavior, and very high density, very hard, and they behave as very good catalyst. Their compounds also act as a catalyst. They show variable valency, more than one valency they show. Then they produce color compound, and their oxides and hydroxide are less basic compared to S block elements. So these are the very important characteristic of transition metals. These are the D block elements. Then next, after S and D, then P block. P block is the last part of the table. Just you see. This is the P block element. These are P block element mainly group 13 to group 18. 13, 14 up to 18. These are called P block elements. Again I am repeating. Group 1 and 2 S block elements. Group 3rd to group 12. 3 to 12. These are called transition elements, and that is 13 to 18. These are called P block elements, mainly non-metals. P block means mostly, or most of elements are non-metals. What are their properties? What are their arrangements? Let us discuss. These are the P block elements, group 13 to 18, and group 13. These are called boron family stuff. First member is boron, that's a boron family. What are these? Boron, aluminium, gallium, indium, thallium. You have to remember the name. It will be very much helpful in your competitive examination. So boron family, what are these boron family? Boron, aluminium, gallium, indium, thallium. They have 3 electrons in its outermost shell. Then carbon family, that is group 14. Group 14 means 4 electrons in their outermost shell. These are carbon, silicon, germanium, tin and lead. These are the carbon family. Group 15, these are called nitrogen family. Nitrogen, phosphorus, arsenic, antimony, bismuth. These are nitrogen family having 5 electrons in the outermost shell. Group 15. Group 16, oxygen family. These are called chalcogen, oxygen, sulfur, selenium, tellurium and polonium. These are called chalcogen and these are called oxygen family. Group 16. Then group 17, these are called halogens. Fluorine, chlorine, bromine, iodine and astatine. These are called halogens. These are called which halogen family. Then last group, these are called noble gases, very chemically very inert. That's why these are called noble gases. What are these? Helium, neon, argon, krypton, xenon and radon. These are called noble gases. So if you see this green color, these are non-metalloids. These are non-metal, that is metalloids, and these are pink color. Almost all are non-metals, and these gray color. This is almost these are metals. So P block mostly contains maximum number contain non-metals, and some members are metals and metalloids. So these are P block elements. Mainly, what are the properties of P block elements? P block elements, these are because the last electron enter in P subshell, and they are starting from group 13 to 18, and it contains 3 type of elements already discussed: metal, non-metal and metalloids. This group contain all 3 states: solid state, liquid state and gaseous state. Some are solid, some are liquid and some are gases, and some are also so variable valency, stronger oxidizing agent. You already know it has a high tendency to oxidize other. Very stronger oxidizing agent, that means high tendency to gain electron. So all P block elements must have very strong oxidizing character. And so catenation property. Catenation property means long chain compound they produce. The atoms are joined one another in a long chain form. That's what this is called catenation property. And there's also allotropic form. Allotropic form means the different structures. Different forms of elements having different structure, like your carbon has mainly two types of allotropes. These are diamond and graphite. So non-metal shows allotropic modification, and most of them produce acidic oxide. Very important thing is non-metal oxides are mostly acidic, but metallic oxides are basic. So these are very important properties of P block elements, and the property also differ from S and D and F block elements. So after P block, the last block remains, that is your F block. F block mainly divided into 2 parts. It is placed below the periodic table. This is first group. First period is called your lanthanoids, and second one is actinoids. And their properties, you see, they are heavy. They are also heavier than tungsten metal. They are somewhat very heavy. Then high melting and boiling point. They also show variable valency. They also produce color compound. And most of this pink color, the last actinides, all are mostly radioactive. Radioactive means highly reactive. They all produce highly reactive elements and produce harmful radiation. These are called radioactive ray, and produced from these elements. These are called radioactive elements, and these elements are discussed separately, not with the normal elements, because their property is highly radioactive. So these are some important characteristics and the arrangement of elements in the periodic table, the all arrangement based on particular periodic laws. Okay, so the elements are classified on the basis of their properties. It may be on the atomic weight or maybe in atomic number. So this is regarding the classification of elements. Okay, thank you.